Before we get started on the lesson today on this note sheet, are there any questions over any of the homework that we've had so far? Any question on any of the homework assignments? Okay. Now, what we're doing today and what we'll be working with here, these problems, this problem here, isn't any different than what we did yesterday and the day before. It's just that there's going to be more steps to it. Bless you. In this one here, we do have two radicals that we're going to have to simplify out when solving. Now, since we have more than one, our first main step was to get the radicals by themselves. If we have more than one, try to even them out. And here, we do have them pretty evened out. We do have one on one side and one on the other. So what that means we can do at this point is to take both sides to the nth power, which in our case would mean squaring them. Well, it'd be helpful if I actually squared the entire right side, not just the radical. We need that entire term. Now this does work pretty nicely on the left-hand side because the square root and square here will cancel, leaving us with 2x is equal to. Now unfortunately the right-hand side won't simplify as easily because what we're saying is that we have the square root of x plus 7 minus 1 times the square root of x plus 7 minus 1. Not completely, because we're going to have to actually distribute and multiply them out. Now the left-hand side is just going to be 2x. Now over here on the right-hand side, we're going to have to multiply through. So we're going to have to take the square root of 7x, x plus 7 times square root of x plus 7, which is going to give us square root of x plus 7 squared. So that square root and square will simplify out when we multiply the first one by itself. Now we're going to have to do the next distributive property is square root of x plus 7 times negative 1, which will give us negative square root of x plus 7. And then we'll multiply with the negative 1, so negative 1 times our square root of x plus 7, which is negative square root of x plus 7. And lastly, it's going to be negative 1 times negative 1, which will give us plus 1. Now we can simplify and combine some like terms here. Well, the 2x is going to stay 2x. Now our square root of x plus 7 squared, well here the square root and square would cancel, leaving us with x plus 7. We do also have the plus 1 at the end that we can move over. If we wanted to at this point, we could have just wrote plus 8 because 7 and 1 will give us 8. Questions on this so far? Now, when we talked about addition and subtraction with radicals, we can add these two together. Or really, we can subtract them from each other. Thank you. Since they are the same radical, we can subtract them from each other, which negative 1 minus 1 would be negative 2 square root of x plus 7. Any questions on any of this so far? Now we still have some combining to do because we can add the 7 and 1 and work this here. But after doing that squaring both sides, we've gone from having two radicals down to one radical. Because the only one that we have left is the square root of x plus 7, yes? So at this point here, where normally on the last ones we would have been solving by now trying to find the value of x, now we just have to go back to what we did originally and get that radical by itself. So whenever we have more than one in squaring, putting both sides to the nth power doesn't remove all the radicals. We just got to do that step again to try to get the radicals to go away. Well, we can go on and add 7 and 1. Now at this point here, we do need to get the radical by itself, so we need to go through the steps again to get everything on the other side. Well, one of the first things we can do in getting the radical by itself is to subtract x from both sides. Our 2x minus x will give us x is equal to 8 minus 2 square root of x plus 7. Well, the next thing we can do is subtract the 8 from both sides. It tells us that x minus 8, okay, try this again, x minus 8 equals negative 2 square root of x plus 7. Okay. Apparently it's not going to do anything. Is the radical by itself? Is the radical completely by itself at this point? Well, no, we have the negative 2. So to finish this off and trying to get this by itself, we have to divide both sides by negative 2, because here the negative 2 divided by negative 2 will simplify, telling us that x minus 8 over negative 2 is equal to the square root of x plus 7. So we had to do all that to get the radical by itself. Any questions on this here? No? Now that we have the radical by itself, what we can do now is square both sides. And the reason we'll want to square both sides is the one side on the left, the radical and the square will cancel, giving us x plus 7. And now, after squaring it the second time, we've removed all the radicals. So with these here, when it works out this way here, we had to do that step twice. We squared it the first time, multiplied through simplify, got the radical by itself, squared it again to get the radical to go away. Now for us on the other side, over here, okay, I'm going to, really we need 2 parentheses, because what we're saying here, all right, stop moving that, is that x minus 8 over negative 2 squared is you're really just telling us that we're multiplying it by itself. All this here is just x plus 7. So we take x minus 8 over negative 2 squared, we're really just multiplying it by itself, so x minus 8 over negative 2 times x minus 8 over negative 2. And we multiply these together, well, multiplying the denominators would be easier to do first, because we're doing negative 2 times negative 2, and negative 2 times negative 2 is 4. We also have to multiply the numerators, so we're going to do our x times x, which is x squared. X times negative 8 is negative 8x. Negative x times 8 is negative 8x. And lastly, negative 8 times negative 8 is plus 64. Any questions on any of this here so far? Now we can combine like terms in the numerator, which would be x squared minus 16x plus 64 all over 4. Now we need to solve this here. Now because we do have the x squared term, we know it's a quadratic, so we're going to have to get this thing equal to 0 and solve for the value of x. Now we've dealt with fractions before, not so much having a quadratic completely in the numerator, but we've dealt with fractions. You've dealt with fractions when solving. You've dealt with decimals when solving. And normally we've kind of had to just work through it, plug the numbers in as fractions or decimals, and try to work that way there. But there is something that is useful in solving that's called a scalar. And what a scalar does is it scales, obviously, scales an equation up or down. It makes numbers bigger or smaller. It changes what it looks like, but it does not change the solutions. It doesn't change what the values of x are that we're looking for. And for us here, the scalar that we can use, incidentally, is 4. And I'm not just picking 4 randomly, and it's based off of the denominator. Because if we multiply the left side of this equation by 4, well, this 4, apparently I'm just going to write over the top of it, and this 4 in the denominator, that 1/4, when multiplied together, give us 1. They will simplify each other out, telling us that the left side of the equation is x squared minus 16x plus 64 is equal to, well, we also have to multiply the right side of the equation by 4 as well, which will tell us that we have 4x plus 28. And that there makes it easier, and we can do this with any equation. So if we deal with decimals, we can multiply it by 10 or a factor of 10, so 10, 100, 1,000, to get rid of all the decimal places. Well, at this point here, we need to get this equal to 0, so we can subtract 4x from both sides. And if we subtract 4x from both sides, it'll tell us that x squared minus 20x plus 64 is equal to 28. But we're still not equal to 0, so we'll have to subtract 28 from both sides. And after we subtract 28 from both sides, we will have this equation equal to 0. Any questions on how we got to this point here? Any questions on anything we've done so far? Well, the last thing we need to do is solve this here. We can solve it by factoring, graphing, or the quadratic formula. Any of them will work. For this one here, we can solve it by factoring, and since the third term's positive, our signs are the same and match the sign of the middle term, which would be negative and negative. Our factors of x squared are x and x. And the factors of 36 that we want are going to be 2 and 18. And if we check this here, x times negative 18 would be negative 18x. Negative 2 times x would be negative 2x, which does give us a total of negative 20x, which would be the middle term that we want. And since that is the correct middle term, we can go on and solve this here by using the zero product property, stating that any two things multiplied together to equal 0 means that one of them must be 0. So either x minus 2 is 0 or x minus 18 is 0. So for the first one, we can add 2 to both sides, telling us x is equal to 2. And for the other one, we can add 18 to both sides, telling us x is equal to positive 18. So the two solutions we found from working this here are 2 and 18. Any questions on this here? Now, it would be good to go back and check and make sure that these both work. And then when we check these, so we can check 2. 2 times 2 equals square root of 2 plus 7 minus 1. We could type both of these into the calculator just as we see them and figure out what the values are and let it tell us what the values are. Or we can work them out by hand. Because if we do it by hand, here 2 times 2 is 4, square root of 4 is 2. On the other side, we have 2 plus 7 is 9, square root of 9 is 3, and 3 minus 1 is 2. So it does tell us that it works. Now we could have typed the square root of 2 plus 7 minus 1 in the calculator, and it would have told us that it was 2. And we could have typed the square root of 2 times 2 into the calculator, and it would have told us that it's 2. Since both sides are the same value, it works. We can check the other side and say 2 times 18 is equal to the square root of 18 plus 7 minus 1. And if we typed the square root of 2 times 18 into the calculator, we would get 6. Because 2 times 18 is 36. Square root of 36 is 6. The other side, we have 18 plus 7, which would be 25. Square root of 25 is 5. And 5 minus 1 is 4. So that tells us that 18 doesn't work, but 2 does, back in the original equation. So out of the two solutions we have, 2 works, but 18 doesn't. Which is a little bit unique because up to this point, all the ones that worked were our positive numbers. The ones that didn't were our negative. So this is kind of the first case where a positive number was one of our extraneous solutions, which is a little bit different, but again, when we check it, we plug it back in. It does let us know which ones work and which ones don't. Now again, I wanted to show you guys this just so that we've seen this at least once. Where we do have one where just using the square, putting the nth power of both sides, doesn't immediately resolve all the radicals. And for the most part, all we've got to do is do it again, and it'll simplify them down. And we might have to do that multiple times depending on the equations. But that's all we're doing today.